Good afternoon. I'm Xian Chen from the College of Photonics National Yangming Jiaotong University. The title of this presentation is the Ultra Robot with the Laser Pest Control. So during this talk, first of all, I will talk about the global trend in the agricultural field robots. For next generation agricultural machinery will be with the electrification, AI, and autonomy. Then I will to our research motivation and goal, how to use the laser pest control in the agriculture. Then I will talk to how to implement this system, this technology. So we will base on the 4 key technology. First one is electric ground vehicle. It's the material operation and mapping. Then we will do the vehicle modeling. Also, we will try to provide a vehicle with the position post. So based on our visual inertial operation, the GPS and the RTK. Then we will try to control the robot, try to follow our reference the pest. So we will use the model prediction control. Then the robot will face the obstacle. So we try to avoid avoidance. So we will use the DDPG to do that. Then the robot will have an eye to recognize nation pest, place the pest, and do the 3D positioning. Then we will use the laser to target it. And finally, I will get some. So as I mentioned, like the John Deere, they say within the 10 years, all the agricultural machinery will phase to electrification, the smart and AI, also the automation and the autonomy. So you also can see the Fed and try to estimate the global agricultural sprayer market. So they say that after about 6 years later, the global market for the agricultural sprayer system will more than $1 billion US. Around the world, for the agricultural machinery startup company also is try to include electronics, electrification, and the AI and the smart, also for the main or the community. So our research is focused on GB, but also for the drone. So it's a sensor, so it's a bit cost. So compared to our research, we use the laser to do the pest control. As you know, for insect pest induce the disaster, especially for the subtropical or tropical country like Taiwan. For right now, the Taiwan, the pesticide are overdue. Some people say it's about 3 times more than the global use. So about a few years ago, people used the laser to do the weeding and repair the bird. Also, you can see the different kind of the agricultural robot being the launch. So original is the chemical control. So for the laser, it's a vehicle control. But you need to move this laser system to your target, to your insect. So it means we also need to integrate this laser system into the UGV, unmanned ground vehicle, or the field robot. So together and try to kill the insect in the orchard. So just as I mentioned, it's for technology. First of all, you need to build the virtual vehicle, and then know the model, and then know the vehicle, the operation. Then you need to control the vehicle to follow your reference pest, and also have the obstacle, like I said, a small animal or even human or some captive. So it means you need to follow. So you use the reinforcement learning, and we also use the AI to recognize insect pest the street. After the recognition, we need to know their position, the 3D, S, Y, Z. So then we will use our laser scanner to targeting the insect. Because the time is limited, so I cannot detail about our technology, but you can reference. But all the program is written by C or C++. It's a robot operation system. We also develop the whole controller process under the mainland Simulink. So just like this, you need to know the vehicle, the model, and to control this vehicle. But for the orchard, not just like the road, the software is a rough and uneven surface in the surface. So we also need to know the instantaneous center patient. So based on the linearization model predictive control, can do the trajectory tracking and pass the file. Also for the avoid the obstacle, we will use the deep reinforcer learning, special on the DDPG technique. Then we will fusion the MPC, just as I mentioned, MPC is for the path following or trajectory tracking, and the DDPG is for the obstacle avoidance. So fusing together, the vehicle can follow your reference path and then to avoid obstacle to reach your target. So this is a test in the field for the obstacle avoidance. So then the vehicle can reach your target. I just say like the tree. Then you need to recognize where is the bomb. So we use the Europe. It will need to do a small object detection. So right now, the worm is small down to about 3.2 centimeter, and the walking distance around the 50 centimeter, we can detect it. But the first time we try to use a laser to burn out the worm, but we need a lot of laser energy, laser dosage. So for the new approach, we are targeting the worm head, because we can use the laser, maybe just about 1% of the original dosage, and targeting the head. So we can let the worm blind or burn out the projector, that the worm cannot find the lead. Maybe I will sketch. So all the systems, the NVIDIA, the TS2 system. So we can precise the laser targeting. So I show you some experiment in the orchard. So you can see a laser targeting the worm, the pest. So we can target in the head. So laser burn out the projector and let the worm fly. So they cannot find the leaf. So this Peter will be died within 2 days. So we can destroy the multiple insects in the orchards. So you can see this video, the 3 insect string. So laser can simultaneously targeting these 3 insects. So after the speed laser explosion, so you can see the worm, the projector burn out. So they cannot find the leaf. Okay, so I will give you some summary. So we developed the unmanned track robot with a laser pest control to do the system can do the in practice. So we have 4 technology. First one is electrical the track robot. As mentioned, we are staying with the VIO, GPS, and we also the modeling and the ICR. And we have 2 technology to control the robot to do the trajectory tracking, also for the obstacle avoidance. So based on the NDC and the DDPG, we also use the Euro to recognize the small insect. So right now, the insects around 3 centimeter and 50 centimeter working distance recognized. And we now use the laser to burn our worm. We use the laser to targeting the head and then the worm fly or burn our layer projector. So the laser target system also can do the very precisely the targeting. The precision is less than 2 millimeter. Right now, we can destroy at least 5 pests per second. Thank you for your attention. And finally, I want to thank the most funding this research. Thank you.